Welcome to our competency-based question series designed chapter-wise to enhance your conceptual learning and understanding. Question 11. A small piece of paper is struck on the surface of the glass sphere of radius 10 cm and refractive index 1.5. The paper is viewed from diametrically opposite side. We need to represent the image formation using the ray diagram, and then we need to find the position of the image. So let's try to draw the ray diagram first. So here is our spherical surface. And for the spherical surface, this is the principal axis. Now the object is placed at the inner side of the sphere, somewhat over here. So this is our O. And this is the center of curvature. And this is the pole for this surface. Now the ray of light, it will move from the object in this direction. And at this point, it will suffer a refraction. So let me draw the normal first. And in this case, the normal will be the ray that is joining the center of curvature to the point of contact. So for the spherical surface, always the normal is the line that joins the center of curvature to the point of contact. And since it is moving from denser medium to rarer medium, it will move away from the normal like this. And here is our eye. So one ray is this, and other one is the ray that is passing through the center of curvature. So it will be refracted with, it will be moved without any deviation. So two rays we are having, they will be meeting somewhere when we extend back this ray. So this is the ray that is coming to the eye, and when we extend it backwards, it will be meeting somewhat over here. So here is the final image that we are getting. So this is the ray diagram for this image formation. So I can say that this is my U, object distance from this pole, and this is my final V, that is object distance from this pole. So we can conclude that this is the ray diagram, and I have drawn it in a better way in this figure. So this is how I have drawn it. Now let's try to find out the position of the image. So we can using the formula for refraction at spherical surface. So we know the formula. Formula is N2 upon V minus N1 upon U is equal to N2 minus N1 upon R. Here U is given to us, and that is the diameter of the sphere. So from the pole, this is the object distance. And the radius is 10 centimeter. So the diameter will be 20 centimeter. So U is given to us as minus 20 centimeter. And R is the radius of curvature of this surface. So this is refracting from this spherical surface. So the radius of curvature will be minus 10. So U is given to us as minus 20 and R is minus 10 centimeter. I can use these values. Also, the value of N1, it is 1.5 and N2, it is 1 because outside it is air. So using these values in the formula, I can write 1 upon V minus 1.5 upon minus 20 is equal to 1 minus 1.5 divided by minus 10. So I've replaced these values N2, N1, R and U by the values that I've just written. So now further I can write it as 1 upon V plus 1.5 upon 20 is equal to 0.5 upon 10. I need to find the value of V. So I can take this towards that side, and it will be 1 upon V is equal to 0.5 upon 10 minus 1.5 upon 20. So let's take the LCM of this. So LCM is 20. 20 divided by 10 is 2. 2 multiplied by 0.5 is 1. Minus 1.5. So 1 upon V is equal to minus 0.5 divided by 20. So when we solve it out, it will become 1 upon V is equal to minus 1 upon 40. So V will come out to be minus 40 centimeters. So this is the distance from the pole. From the pole, it is at a distance of 40 centimeter, but from the object, it is at a distance of 20 centimeter. So it will be 20 centimeter behind the object. So this is the answer for this question.
Keep learning, keep practicing, keep excelling.